Welcome to Homework Lib.
Hi, so in this case, we're going to have a strong acid, which is HBr. So since this is a strong acid, what is going to happen when it comes into contact with water is that it is going to be dissociated into hydronium ion and bromine minus. And we are also going to have a strong base, NaOH, that dissociates into OH minus plus sodium plus. Both of these are going to be in aqueous solution. So the pair that are actually going to react is the hydronium ion with the hydroxide ion. So in order to know the pH, first thing that we need to realize is that we have two solutions that have the same concentration. Okay, so we're adding 25 milliliters of a zero point 0.2 molar concentration of NaOH that are added to a 20 milliliter sample of an acid, HBr, of the same concentration. So when we have a one-to-one correspondence, we can directly compare the volumes. So the amount of matter that we are going to have in 25 milliliters of NaOH, I'm going to label this as OH minus directly because it dissociates. It's going to be the volume times the concentration. But the volume, we need to transform it into liters, as always. 1,000 milliliters corresponds to 1 liter. And we multiply this by the concentration that we have, zero point 0.2 molar. Then we're going to have the amount of hydronium ion that we're going to have in solution, which is the same formula, but with 20 milliliters instead. So the results for each of them are going to be, I'm going to label them directly in our ice table for you to realize that we're going to have an excess of OH minus. I'm going to write down the ice table in terms of mole instead of molarity, the amount of change, and the amount of equilibrium. So for hydronium ion, we're going to have is 20 times zero point 0.2 divided by 1000, right? So hydronium, we have 4 times 10 to the minus 3. And in the case of OH minus, we're going to have 5 times 10 to the minus 3. So which one is going to be the limiting reagent? The limiting reagent is going to be the hydronium because that's the one that we have less. So the amount of change, since this is a quantitative reaction, it's equal to the initial amount of hydronium. At equilibrium, we have close to 0, and of OH minus, we have 1 times 10 to the minus 3 mole. Perfect. So now, with this amount of mole, we can calculate the concentration of OH minus, taking the final volume. And the final volume, in this case, it's going to be simply 45 milliliters, which is 4.5 times 10 to the minus 2 liters. So the concentration of OH minus will be 1 times 10 to the minus 3 mole divided by my volume, which is going to be 2.22 times 10 to the minus 2 molar concentration of OH minus, and this is going to be 2 periodic. Nice. So with the concentration of OH minus, in order to get the concentration of H3O plus, or the pH of our solution, we're going to use the relationship in between pH and pOH. That tells us that the sum of them needs to be equal to pKw, which is 14. Nice. So the pOH for our solution is minus the logarithm of this concentration of OH minus. So we take the logarithm of that value, and that concentration is going to give us a value of 1.65. So pH is simply going to be 14 minus pOH, which will be 12.35. And this is going to be the pH of our solution after we have added the 25 milliliters of NaOH.